Hello everyone. Today we are going to talk about the truss analysis, and I'm going to use the stiffness method for analysis the truss. All right. So here I have taken one questions you can see. All right. So there is a pin joint truss. Okay. This is the pin joint truss. You can see here. All right, and the truss is pin connected to joint 2. You see the joint 2, right? And then joint 3 and also joint 4, and it has area 1000 square millimeter and E equal 200 gigapascal. All right, so the first things I'm going to find out, I will determine the stiffness matrix K for the truss. Okay, so from the second joint to third joint there is a distance is 4 meter. Third joint to fourth joint there is a distance is 3 meter. All right, and then we have the pin joint 2, 3 and 4. Okay, you can refer my color as a blue color as a joint. All right, and the member, first member, second member and the third member. All right, so I want to show you that DOF means the degree of freedom, KU means the unknown reaction, and du means the unknown displacement. So q means the reaction, d means the displacement, okay, and u means the unknown. All right, so now for my first step I'm going to consider this truss, and I already draw and all the direction nodes, and then I already mentions the all the dimension here. Okay, so now we will choose the second joint, all right, as the origin of the global coordinates. So this is our origin, all right, this second joint. Okay, now what we have to do, we have to transfer the local coordinates to the global coordinates. So there is a formula to transfer the local coordinates to the global coordinates. So now I am going to use the formula. The formula is lambda x equal x far, I mean the far point of x and the near point of x. Yes, so we can do like this. Okay, xf and xn over L, and for the lambda y we can find out yf minus yn and divided by L. Okay, in here f means far and n means the near. Okay, so here I also have draw. Okay, this is the far point. Okay, and this is the this is the near and this is the far. All right. Okay, so now what I will do, I have to take the first member. So I am going to take my first member. So for the first member you can see here. Okay, so this is the first member. Okay, so if I want to find out the length here, so basically I will use the Pythagorean theorem. Okay, so I will use the basically Pythagorean theorem. So for the Pythagorean theorem, by using the Pythagorean theorem, what I am getting, I will get the length. Okay, how I will get the length, because this length is 4 meter, also this length, I mean the base is 4 meter, so I have to get the hypotenuse. So I will use the Pythagoras theorem to get it, and I have the 4 meter, so I 4 square I will get the root 32. All right, so now what I have to do, from O, okay, 0 for the xf, for here, okay, this is the near and this is the far. Okay, so in here also we have two x and y coordinate, and for here we have also x and y coordinate. So you can see here, so for this point we can see it is far, right, and this is the near. Okay, so the far x is 0. See, far x is 0, and this 4 we consider it as near x. All right, so I take it as near x. So I just transfer this all local coordinates to the global coordinates. So what I will do, I will take like this, I will put the value, plug in the value, and I will get negative 0.707. All right, so now I will get the lambda y value. Okay, for the lambda y value we will get 0 and 4. I will divide it by root 32 because this is the length, and I will get the same value 0.707. all right, Okay, so now I already know the formula. What is the formula for the stiffness matrix? We have the formula K equal AE over L, and we have to mention the near N, near Y, far X, far Y. All right, so this is the formula. Now it's our time to plug in all the values into the formula, and we can do. And for easily, if we want to plug in, so we can find out the some value here. Okay, so in formula you can see we have the lambda x, right? So if we do the lambda x square, then we can easily get the value. And wherever we have the lambda x, lambda x, lambda x, lambda x, lambda y, lambda y, lambda y, and lambda y, so that's mean easily you can finish your 3, 3, 6, 6 to 8 value. You can substitute by using the square. Okay, all right, then you can do the x and y, you can multiply. So if you multiply x and y, in this case it will be 0.499. so what I'm going to do, I'm just going to plug in all the value in here. All right, so why I'm writing like in this way, 1, 2, 3, and 4, because I already mentioned you we have to find out the near x, near y. Okay, all right, so this is the for our member one. So this point is the near one, right? So in the near one we have the x1, y is the 2. All right, for the far one we have the x is 3, y is 4. So that's why I write here 1, 2, 3, and 4. The same way I will follow here also, nx, ny, fx, and fy. All right, so now I'm going to discuss about the member 2, I mean the second member. So you can see the second member, 1 is the near and the end, and 3 is the far end. Okay, so if I go here, all right, so if I see the second member, in the second member you will see the near one is 1, 2, and the far one is 5 and 6. All right, okay, so here also I just find out the length. So in this case we directly get the length 4 meter. Why I will get this 4 meter length from where? Okay, so you see this is the length 4 meter. All right, all right, then in here already I got the length. So in the same way what I am going to follow, I will follow the 4 meter for the near far x. Okay, you can see the far x is the 4 meter, and for the 4 meter for the near x. All right, so after that I will plug in the value into our formula, and in the same way I will follow for the lambda y, and then whatever I get the value from lambda x and lambda y, so I will plug in the same way that I did for the member 1. So all right, so in this case we have the 1, 2, 5, and 6. This is the near one and this is the far one. So that's why near x, near y, far x, far y, near x, near y, far x, far y. All right, and then we have the member 3. So now in the member 3 you can see that since 1 is the near one, near end, and the 4 is the far end. Okay, how I get it? Okay, if we go there you can see the 1 and the 4, right? So number 1 joint is the near end, and the number 4 is the far end. All right, so in this case we have the 1, 2, as x is 1, 2 is as near y, so 7 and 8. All right, so in the same way I have to follow the lambda x for the third member. Okay, so for the third member I can see here. So first of all we have to find out the length. So for this length we know this is the 4 meter, right? And for here to here we have 3 meter. So if I want to the hypotenuse, so how I can get, I use the Pythagorean theorem. So 3 square plus 4 square equal root over 25, and I will get the 5 meter. So the length is already we know, and this is 5 meter. So now it's time to get the near x and near y, far x, far y. All right, so for the far x, so the if our like now we are going to find out the lambda x, right? So for that's why we will find out the x value for far end case and the near end case. Okay, you can see here for the far end we have the 7, right? Okay, so 7, and for the near one we have the 4. Okay, so I just subtract, I will get 0 0.5, then substitute the 4 meter for the yn. Okay, why I'm getting the 4 meter, you can see this is the y, and okay, so 0 is the far, you see the far is 0, and for the near end we have the 4 as y value. So what I'm going to do, I'm just using the same method to do the subtraction, and I will get, if I divide it by 5, I will get negative 0 0.8. So if I want to quickly plug in the value, so that's why I have to I can do the lambda x square, lambda y square, and lambda x and y. Later I just plug in the value as the sign. All right, and for in this case near x, near y, far x and far y. So for third member we have the near one, near end was 1 and 2, and far end was 7 and 8. So that's why I write the near one 1 and 2, 7 and 8. So after that I will plug in the value. So what I will get, so in this case I can see that total like I have 3 members, so that's why I find out for the stiffness matrix for 3 members. So I get k1, k2 and k3. So now it is time to do the addition. All right, so what I'm going to do, I have to do the metric addition. So for the matrix addition we have to follow the same row and same column number to add two metrics. All right, so this is the basic things to do the metric additions, that we if we have the same row and same column, then we can add this one. So I want to show you some example. So I forget to mention, so this is 8 times 8 matrix. Okay, that's mean we have the 8 column and we have the 8 row. All right, so now for this case, okay, for this one, so we can see this is the first column and this is the first row, right? So we have to go in our 3 stiffness matrix. There has first column, you see the first column and first row, right? So I will get 0 0.70, 0 0.072 plus. All right, so if I go for the second member, I have the 1 and 1. Yes, 1 and 1. So 1 and 1 is value is 0, so I put 0, then plus. Okay, so for the first one also I have the for the first member I also have 1 and 1, so 1 and 1, so it is 0 0.088. So I plus 0 0.088, so I will get 0 0.16. okay, so that's why I write 0 0.16. So in this in this way I can do the matrix addition. So I want to show you another one. So for this one we have the 8 number 8 column, okay, and the second row, so 8 2, we have to follow the 8 2. All right, so you can see in here 8 2. Okay, so what is the value, negative. Okay, I put negative 0 0.128, then I have to plus, right? So I have to search for other one. So in here I cannot see anything. Okay, for the first member also we don't have any value for 8 and 2, so I get negative 0 0.18 as the 8 and 2. All right, so after addition, so the like if I summarize my presentations until the stiffness matrix addition, so what we can do, first of all we have to find out the like the global coordinates. All right, so what we have to do, we have to find out the origin of the global coordinates. After that we can find out the member 1, member 2 and member 3. Then for each member we have to find out the stiffness matrix. All right, for the stiffness matrix, if we want to find out the stiffness matrix for every member, so we have to find out the lambda x and lambda y. Once we get the lambda x and lambda y for each member, then we can get a stiffness matrix for each member. After getting the each member's stiffness matrix, what I can do, I can add all the matrix together, and I will apply the matrix addition to get the K stiffness matrix. All right, so now we have to move for the seventh step. So in here, like once this structure stiffness matrix is formed, so already I formed it, right? Okay, so what will happen, the global force component Q acting on the truss can then be related to its global displacement D. Okay, so we have you, like we will use the one formula. So the formula is Q equal KD. All right, so in here what we have, so we have the Q is 2, okay, for -2, and for 0 this is for 1 and 2. All right, and then what we have, so QK equal the known external load. So if we go there, we can see, is there any loads in here? Yes, so this is the external loads, right, that is acting on the truss. All right, so after I find out the QK value and the DK value, so DK value is 0 0 0 0 0 and 0 for the D3 to D8. All right, so now I will apply the formula. Okay, Q equal KD. So in this case we have the Q already, we have -2 and 0, right? So in here we have 1K. So if you have the QK, so in this time, this for the same number you will get the unknown displacement. All right, so you see that we have the Q1 and Q2. So in this case we don't have the D1 and D2 known, right? So we have the D1 and D2 is unknown. So what we have to do, we have to partition the matrix. So we will partition the matrix, okay, until this. So I will write -2 0 as the QK, I mean the external force, and then AE. Okay, then for 1 and 2. Okay, so in here why I'm writing, so I am writing because K11 and K12, you can see the reference book, and from there I am using this formula to get this value. All right, so we have in here D1 and D2. So what we have to do in this case, so you see the -2, right? So -2 I put AE, then I use the matrix multiplication, you can see 0 0.00, then I will multiply with D1. Then okay, we have the formula plus from the formula, but what in this case, if I put plus and I have the negative, so negative and positive will become negative, right? So that's why I put negative directly. All right, so 0 0.007, then I multiply with D2. This we can, you know, like form it as a equation number 1. All right, in the same way I will follow the 0 equal this second equation. So when we will solve, like when we will, you know, form the first equation and second equation, what we have to do, we have to find out the area, okay, and the E. So already area and the elastics value 200 gigapascal, it's already given. So what we can do, we can use the simultaneous equations to solve the D1 and D2. So we can use the formula, so we can use the calculator to get the value. By using the calculator we can get easily simultaneous equations value D1 and D2. All right, so once we get this D1 and D2, then we have to follow the, and you know, we have to calculate the force for every members. Okay, so in this case there is a formula to getting the value of force. So what will happen in here, you can see the QF equal, I mean this is the force. All right, this is called the internal force. Okay, and AEL lambda x lambda negative lambda x, negative lambda y, lambda x, and lambda y. So this is the formula. In this formula, so in this questions you can see. All right, I want to see you. Okay, in this question they say, okay, calculate the horizontal displacement J1, joint J1, and the force in the member 2. All right, so you know already we find out the horizontal displacement. So now I am going to find out the force in member 2. All right, this is the force in member 2 that I am going to find out, Q2. Okay, so all right. Okay, so what I'm going to do, I'm just going to plug the value. Okay, for the member 2, the question asks us to find out the force in member 2, so that's why I take the member 2, and in this case I have to take the length of member 2 and the lambda x value that I got for the member 2, and for the lambda y value that I got for the member 2. So what I'm going to do, I'm just trying to plug in all the value in here, and now you can ask me dy, d1, d2, d5 and d6. So I am taking it because this is the far end point and the near end point for the member 2. All right, so that's why I take 1, 2, 5 and 6. All right, so I have the ae 4, then negative lambda x equals 0 I got in here. Okay, for lambda y I have the 1, then for the lambda x I have 0, and for the lambda y I have the -1. So this is the things that I am going to write here. So once I got it, then I have the -1 by y, then I have another value that I already got for the d1 and d2. You remember d1 and d2, so you can see here we have the d1 value, d1 value, d2 value and d2 value that I substitute from the simultaneous equations. All right, so if I do, you can see in here ae and here also ae, and they are in the multiplication relation and the divided, so we just eliminate this two number ae and ae. So what will happen in here, so in here you can get 1/4. All right, then here if you apply the matrix rules, then this number will become 0, and for this one also become 0. So and for -1 also becomes 0, because why? Because this -1 will multiply with this 0, right? So it will become 0, but only the one, okay, this one, if I multiply this number with the -0.18, so it will become 0.045. We just can get the q2, I mean the internal force. Okay, so by using this formula we can get internal force for every members, not only for the member 1, we can got as well as member 2, member 3, member 1, no problem. Okay, so in the same way we can, if we follow for the member 3 and member 1, we can get the internal force. Okay, all right, so now what we have to do, we have to find out the thermal changes. Okay, so if I go back to the questions, and the question C, if the temperature is increased by 55 degree, analyzes the force in member 2 and take alpha equal 11.7 10 power -6. Okay, so I will go back to my answer. Okay, so in this case what we have to do, so for the member 2, all right, so I'm going to follow the thermal changes. Okay, so the temperature is 55 degrees Celsius, that is changing. Okay, and the alpha value is equal 11.7 multiplied 10 power -6. So I have to apply the formula for the case there I am going to get the thermal change. Okay, so this is the negative a, e, alpha and t. So we know the a is the area, we have to subtract from the internal force. You can remember as that we done just before. Okay, a, e, alpha and t. So we have the a value 1000, the e value is 200, and alpha is 11.7 multiplied 10 power -6, and the t is 55 degrees Celsius. So what I'm going to do, I'm just I know for the value d1 and d2, and d5 and d6 is 0 and 0. Okay, so d1 and d2 I already show you that how you can get, and d6 and d5 is 0 0, because the displacement, non-displacement was 0 and 0. All right, so if I do subtract, then I will get the thermal changes value. So now I will show you for the external force, q3, q4, q5, q6 and q7, how we can find out. Okay, all right, so how I will get the q3 value. value. Okay, so for the q3, q4, q5, q6, q7 and q8, so what I have to do, I will go back to the matrix partitions. Okay, so I had q1 and q3, so that's why by using this value and doing the partition, then I get the d1 and d2, right? So in this case, I don't have the q3, q4, q5, q6, q7 and q8, but I have the displacement value 0, 0, 0, 0 and 0. So what I do, I will try to do the partitions for getting the q3, q4, q5, q6 value. So the same way I will use. So you can see we have to label. Okay, so in here you can see for the 1 and 2 value negative 0, 0.088. So in this case I will do the partitions. Okay, I did the partition here. So what will happen in here, so I just use the formula. So in this case you see the d1 d3, d4, d5, d6, d7, d8 value is 0, 0, and q3 to q8 we don't know the value. Okay, this is the external force that we don't know, but we are going to find out. And there is a formula that I multiply with 1 over e negative 12.5 and 0.18 that I got from the simultaneous equations. All right, so if I want to get the q3, what I have to do, q3, right, q3 equal sign. Okay, then I'm just like following the matrix calculations. Okay, so the first number is 0.088 negative. All right, so then what I have to do, we are going to multiply, right? So multiply, then we have the plus, then 0. Okay, so in this case there is no sense to add 0, so that's why I ignored the 0. All right, for the second one, you see the second one negative 0.088 for the second column value 0.088, and then I multiply with the second value 0.18 negative 0.18. So what I will get, and if I plus 0, so I will get the reactions for the q3, q4, q5, q6 and q7 and 8. We can just follow the same way. All right, okay, so I want to show you that okay, ae and ae we haven't calculated because we can just eliminate it, okay, from the equations. Thank you so much. Hopefully you can solve now by your own self. Thank you.